given that x is in y and x is in z, should x complement intersection y intersection z. So this is y, this is z, and we are told that x is in y and x is in z. So this is x. So this is x. Or we can put it inside. This is x. Then to shed x complement, but you must be in the intersection of y and z. X complement intersection y intersection z. So you're outside x, but in y at the same time in z. This is the reason why you must be careful when reading this question. It is not surprising if you find yourself thinking that this is y, this is z, and this is x. It can also mean that, except that there is no emphasis, there's no statement which says that the whole intersection is x. The question is just saying that x is in the intersection of these two, not that it is the intersection. So you don't find yourself reasoning like this. It's dangerous.
So repeat on the shading part, please.
So you shed nothing x, you're shading outside x, but that outside of x should not leave the intersection of y and z. You make sure that whatever you shade is in y intersection z, but not in x. That's why the shading appears like this. Given that C intersection D is empty.
Sir,
Simplify. C
can you repeat that question?
I can't make it. Time to write a message. The message is starting. The voice is starting.
Sir, it's sir,
Hello?
I'm
Hello, can you hear what you say?
Excuse me, sir.
Hello.
Excuse me, sir.
Hello.
Yes, so say that. Do you mind repeating question on the part of shading?
Okay. Shading. We are given information that we are relying on.
Sir, I just joined. Did you start a long time?
Yeah, we started the wrong thing. I don't know what you mean by joining. You mean in this session or in the previous session?
Today.
Okay, we started the wrong thing. That's our second session. But we record them. So if X is in Y,
All right. Good. And then
if X is in Y, then I know that in Y I'll have X. This is my X. X is also in Z. And it means that this area of Y that has X is also in Z. Now shade everything that is outside X, that is X component. But intersection, meaning that thing which is outside X, it must be in Y intersection Z. But Y intersection Z is only this part here. You haven't shaded anything that is in X. You have not gone outside the intersection of Y and Z. So given that C intersection D is empty, simplify this. Now we understand very well. And we did mention yesterday that De Morgan's law, we have two of them actually. This guy De Morgan, he gave us two laws. He said that if you have A intersection B, the complement outside, you can as well choose to go by A complement union B complement. The same guy actually said, if you have A union B complement, you can as well go for A complement intersection B complement. Why do we want to talk about De Morgan? Because we have a situation here that looks like one of the things that he said. He said that if you have C complement union D complement, which is here, you can choose to present it in the intersection form as C intersection D and then take the complement outside. Why do we want C intersection D? Because we are taught that it is empty.
Sorry, repeat your statement.
So from De Morgan's law, we are taught that A intersection B complement outside is the same as A complement union B complement. Meaning, even if I have not seen A and B, I see C complement union D complement. I can write it as C intersection D complement. Why should I insist to have C intersection D and not C complement union D complement? Because the question has given us a condition that C intersection D is empty. So we want to put empty here because we know something about empty. This intersection empty. Empty what? Empty complement. But we know that the complement of an empty set is the inverse set. Where E is the investor set. But any small set intersection the universal is that small set. Because we know that C union D is a subset of E. Because E is the universal. Being the universal is that you hold everything that exists. So if it exists somewhere, then it is a subset of that thing, which is the universal.
So I'm asking for the previous board.
So I'm asking for the previous board.
Rationalize the denominator. One over the cube root of x to the power 4. So you say you can write this as 1 over x power 4 over 3. That's what it means. To rationalize this, it means that we must remove the powers of x in the denominator and leave x standing alone. The only way we can do that is by making sure that the power of x here is 1.
Excuse me, sir.
Hello?
Hello.
Hello?
Yes, sir. I'm asking on question number 3 to say, what if we had the 3 sets whereby we had C, D maybe an E, and for instance E hasn't been included in that question? Can the answer still be C union D?
Don't use E, guy, because E is here.
Oh, sorry, or maybe we use G. We had
So,
C, D, and G.
where G is a subset of E, the universal, is it?
Yes.
The answer wouldn't be C union D. It would be C union D intersection. That's it.
All right. Yeah, thank you.
So here we want when they say rationalize, they are saying make the power of x in this denominator to be 1. So how do you make this power to be 1? You say, okay, what can be 1 minus that thing which is there? You get 3 as a common denominator. Then you have 3 minus 4, which is negative 1 over 3. This means that if you multiply this thing by x to the power negative 1 over 3 in the denominator and also in the numerator, then you're going to have x to the power negative 1 over 3 over x to the power 4 over 3 minus 1 over 3. but this is x to the power -1/3 over x power 1.
Sir,
Hello?
so just start from the first, like how you done the question, the same rationalize.
Yeah. When you are given a number like this one, 1 over the cube root, this thing which sits here is the denominator of the power. So if there is a 4 here, then you can write this as 1 over x to the power 4 over 3. When they say rationalize, they mean get rid of the powers of x or make the power of x 1 in the denominator. So you're looking for the powers of x. You're looking for an x that when you multiply here and add the powers, the power of x will be 1. The easiest way of doing that is you get the existing powers of x and subtract from 1. This will give you -1/3. So you bring it here, -1/3. In the denominator, whatever you do in the denominator, you also do in the numerator, -1/3. So that you have x to the power -1/3 over x. You have rationalized.
Sir,
Hello.
if we had a 2, would have subtracted 2 from 1/3.
If we had a 2 where
On the numerator.
if we had a 2 here, like in the question,
Yes.
this subtraction has nothing to do with the numerator. It has everything to do with making the powers of x 1 in the denominator. So even if we had 100 there in the numerator, even if it was 100 over the cube root of x power 4, you are going to do the same thing and 100 will just stick here. To rationalize is to make the power of x in the denominator 1.
Yeah. Okay, sir, thank you.
Okay. Hello.
Which one of the original equation I can't connect my message happy please.
The original equation was this one.
So
What am I saying that you can explain again?
Okay. Oh, what's the other question?
Oh, my question is, what if you downgrade the denominator by separating the first root in there, or the power 4 into x to the power 3 and x to the power 1, so that the cube root and the x can cancel? Then you also upgrade it by multiplying with the cube root of x squared so that it can cancel again. Can that be okay?
When it cancels, what will remain in the denominator?
When it cancels, what will remain is x multiplied by x cube root of x.
The question says rationalize, so you don't need anything cubed in the denominator. So that cube should appear up there as a negative power. So it will be correct.
All right, thank you.
Okay. Hello.
Sir, why can't you just take the x up? Like the x 4/3. You take it up and say you give it a negative and put it in the numerator.
That is not rationalized. Do you know that if you have 1/2 plus root 3, they tell you to rationalize? If you
Sorry,
could do,
sir.
if we could do that, then we would have been saying, just do that.
Oh, okay. So, sir, you have to think of a number, or is there
So
any way you can?
and that is actually the way. The question is 1 over the cube root of x to the power 4. So you say 1 over, the easiest, you rewrite this, power 4/3. Then get this power, whatever it is, subtract it from 1. Because we want to rationalize is to make the power of x in the denominator 1. So find the number that when you add to this power, the power of x will become 1. That number is easily found by subtracting from the one that you want to have. So you have 3 minus 4, which is negative 1/3. So you know now that when I come here, I'll have in the numerator x to the power negative 1/3 over x to the power 4/3. To avoid changing anything, even down x to the power negative 1/3. If they say give us back the question, these two can cancel. Okay, that is rationalize. Whatever you do in the denominator, you also do in the numerator. So you have x to the power negative 1/3 over same base. Exponential is telling us that if you have same base, you add the powers. So you get x to the power. You have rationalized. So having x, if you write this as 1 over x, cube root of x, you have not rationalized, but you have found it. It's correct, but it's not rationalized because this thing is still in the denominator. So give it a negative power to show that you understand that rationalization means I should not have anything root in the denominator. It will sit there in the numerator, though indicating that I'm coming from the denominator. Any questions? You can have a good night.
I think.
Sir. Sir.
Hello,
Sir. Are we done with it?
we're not done.
Oh, okay.
Okay.
So even in the next session, we're doing sets.
Yes.
All right. Okay. All right. Thank you.
Now, so
Uh-huh.
At that stage where we reached to say 1 over x cube root of x, what if we decide to rationalize it by multiplying both the numerator and denominator by cube root of x to the power x squared, cube root of x squared?
To sit in the numerator. Whichever way to sit, it will be telling us that it is this.
Oh, okay. I get it. Thank you.
It is from the subtraction of 1 minus 4 over 3. Do this subtraction, Elizabeth.
So, okay, on the denominator, before getting to the official answer, what happened to 4 over 3 minus 1 over 3?
What happens?
Yes, because there the final answer is showing x is to the power 1
What's
over
the
3
common
negative
what's the
over
common
8.
denominator here? The common
That's
denominator is
3.
3. Then you have 4 minus 1, which is 3 over 3. This is 1.
1. Okay.
Excuse me, sir.
Okay.
Are you going to send the recorded video?
Yes.
All right, thank you.
Okay.